Hey everybody, it's Mr. N here, and today we're going to be talking about dilations. So, let's first start out with what a dilation is. A dilation is basically the same as applying a scale factor, and we're going to call that scale factor K. So, here's the terminology, the dilation about point O with a scale factor K. This means that I'm going to dilate with a center of dilation at O, and I'll have a scale factor that's going to be K. So if k is greater than 0, p prime lies on ray OP and OP prime equals KOP. If k is less than 0, p prime lies on the opposite OP ray and OP prime is equal to the absolute value. This just means if the scale factor is positive, we will move in a positive direction when we enlarge or reduce the item. If the scale factor is negative, we will be moving in a negative direction. Okay? So, in other words, if my scale factor for my point of dilation is this, p prime will be there as long as it's positive. If it's negative, then I will move in the opposite direction. And we'll do some of those with some examples. And then, again, if the absolute value of k is greater than 1, and I say absolute value because I'm looking for just the value, that's an expansion enlargement. If that absolute value is less than 1, such as a half, a third, even if I put negative in there, negative is just going to tell me go in the other direction, but then that 1/3, if I have negative 1/3, that tells me that I'm going to reduce it. It'll be a reduction or what we call a contraction. Okay, so a dilation is a similarity transformation, but it is not going to be an isometry because we're enlarging something or we're reducing something. So if you look at this example, here's my center of dilation, and if my scale factor is k from here, that means I will move that distance k again the other way from the center of dilation. So here's another graphic. If this distance right there, I will take that other distance, whatever the scale factor is, from it. So if the scale factor is 3, I will go 3 from it. All right, so we said it's not an isometry. And then a dilation maps a angle to a congruent angle. So angles will still be congruent. And the segment will be parallel k, absolute value here, k times as long. So that's where we're changing that. And if you have a polygon, you have the area would be k squared. We could think of it that way, right? So if you're enlarging it, then the area of that polygon will be k squared. Okay, let's move on to the next page. Let's take a look at what we have here. I'm going to enlarge this a little bit. I'm going to dilate it. That was my joke there for this lesson. So if the scale factor dilation is negative, we said we're going to be going in a negative direction. So the preimage is rotated by negative 180. For k greater than 0, with a scale factor of negative k, is equivalent to a composition of a dilation with a scale factor k rotated 180. So in other words, if this is my preimage, my scale factor k, I would enlarge it out to here if that's my center of dilation. And if it was negative, it would go in the other direction, but notice how it would look like it's rotated 180. If the point xy is the preimage of the point under dilation and the center at the origin with a scale factor k, then we're just multiplying it. So basically, all of this is just going to tell you, you're just going to multiply the x and y points by whatever the scale factor is. That's the simplest thing. This is how we're going to do it in a coordinate plane. This is the biggest thing you should get out of all this, is we're going to be multiplying the x and y by that k scale factor, and all of this that we've talked about will just happen all on its own. Okay, so let's just do some examples and see how we end up with these and see what we end up with. Right here. Find the image of triangle ABC under the given dilation. Okay, so for this first one, they're asking me to dilate by a scale factor of 2. And I didn't label the points here, but let's go ahead and we will label these points A, B, and C. And whatever this distance is, can't draw it so well with this, okay, I would double it since the scale factor is 2, so that would be my new point A. Whatever the distance is to B, I would double it. That would be my distance to B now. And whatever that distance is to C, I double it. There's C. This, let me make it in another color, see if I could do it in another color, is my new triangle, the enlarged triangle. All right. Let's take a look at the next example and see if we could come up with these points. It says A is at -1, 0. B is at 2, 2. C is at 3, -2. We need a dilation about the origin by a scale factor of 3. So let's determine what the new points are. We would have right here A prime, and that would be the point by a scale factor of 3. So we're going to multiply it, so -3, 0. B prime would be at 6, 6, and C prime would end up being at 9, -6. For the next one, the scale factor is -1/3 about the origin. So let's just do another color here, and we will have A prime, and that will be -1/3 times -3, which gives me 1, 0. B prime, that's going to be 6 times -1/3, which would be -2, comma, 9 times -1/3, which would be -3, and C prime, that would be 3 times -1/3, -1, and then -6 times -1/3, which would be 2. And there's your A prime, B prime, C prime. Okay, number 4 does have a mistake in the problem. They didn't give us the coordinates, so we're going to go ahead and skip that. We will just do the rest in class. As I take a look at this, we're just going to do the rest in class, which are the ones out of the student journal right here. All right, quick video today. Thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video. Let's see if there's anything else that I want.